You're here on time and you have to leave, but don't see anyone else coming. So the workshop is going to be for you. Okay. So first problem, we have a function of x, and they asking us to find the vertex, axis of symmetry, the intercept, to graph the function, and then at the end we're going to find where the function is increasing and decreasing. Okay. So first, to find the vertex, we have a formula. X equals negative b over 2a, right? And if you look at the function, this is a, this is b, and this is c. So we're going to plug in the numbers. Negative, and then we have negative b. Always make sure that you use the negative from the formula and the negative of the number. That is a trick. Always, they're going to get you there. That is going to be over 2 times negative 1. So negative and a negative is going to give me a positive a. 2 times a negative 1 is going to give me a negative 2. If I divide a by 2, I'm going to get 4. And negative and a positive is going to be a negative. So my vertex is, the x is negative 4. And now we have to plug back in the function, the negative 4. To figure out the y value for the vertex. So have a negative, open parentheses, negative 4 raised to the second power minus a, open parentheses, negative 4 minus 15. That is just a calculator program. One. That's right. So y is going to be 1. How do we want the vertex? The vertex should be given as a point. So my x is negative 4, comma 1 for the y. Now that we did this, it's easy to answer the axis of symmetry. We did it already, so you only have to label that. Axis of symmetry is going to be x equals negative 4. It's the x values for your vertex. Next one, intercept. I'm going to rewrite the function. Negative x squared minus ax minus 15. Now, to find the x intercept, we're going to substitute our y for 0. So we're going to have 0 equals negative x squared negative ax minus 15. What we need to do, factor. Open a set of parentheses. Oh, I don't like that negative there. So the first thing that I'm going to do is to put negative 1 as a common factor, so I don't have the first term as negative. So you're turning everything by negative 1? Negative 1. So everything is positive? Yes. Everything is going to be positive. So now, how you factor? Open a set of parentheses, find the factors of x squared. That's going to be x and x. The first sign, you just bring it down, positive. To figure out the second sign, you multiply positive and a positive. It's going to give you positive. Now the factors of 15 that added together, because the signs are the same, will give you 8, 5, and 3, right there. And when you solve for x, you're going to subtract 3 on both sides. This cancels, and you have x equals negative 3. And here is going to be x plus 5 equals to 0, Subtract 5 in both sides of the equal sign, cancel 5, and now we have x equals negative 5. The same as before for the vertex, we need to have a point. If we call y to be 0, we have to make sure that our y is going to be 0 for the x-intercept. So a point is going to be negative 3, 0, that's one of the intercepts. Now, that's not what I meant to write. So now we have negative 5, comma 0. Now we're going to look for the y-intercept. We're going to do the opposite. We're going to equal x to be 0, and we have to write again the function. We have the function of x negative x squared minus ax minus 15. If we substitute every x by 0, that really is going to be really easy. Minus 15. So this completely cancel, and we have the f of x, f of 0, sorry, it's going to be equal to negative 15. Mm-hmm.
Right? Do the x after that. You have to set to like
when we factor, it's kind of hard to factor when the first term is negative. It's easier to just pull out a negative 1 as a common factor, just to make it easier for you. So then when you start factoring, so you're going to have one x to be positive, the other inside the bracket, another x to be negative, and then to get the signs, yes. It's a lot easier if you make your first term positive. If I will have any number in common, if I will have 2, maybe 4, and 8, so I know I have the 2 in common, I will put our negative to force everything. I don't care about the rest, but to force the first term to be positive.
Okay.
That makes it easier on you.
Yeah. And then what the y is just because you don't factor in the x, you don't factor.
Because we're not factoring. We don't have to factor. Always to find the x-intercept, we have to factor because we have the quadratic. We're going to have the trinomial, so we have to factor. In this case, we basically want to cancel everything, and we ended up only with the coefficient, which is the number, the constant, which is the number at the end by itself. Keep on asking questions because those are good questions, and you need them for the test.
Yeah. Does that make? I'm trying to like kind of make sense to you.
Mm-hmm.
I mean, the numbers have a problem.
The concept
With
is
the concept behind it.
And here is the step. If you learn how to do one problem and you understand what we're doing, you will be able to mimic that. Because it's going to be the same. Always to find the x-intercept, you're going to substitute y by 0. You're going to end up factoring most likely. Then you have to have your point. Then when you go to find the y-intercept, what you always need to equal your x0. You're going to cancel some terms, and you're going to end up with your coefficient. The concept not always going to be like that, but it's really close to what most likely is going to be happening when you solve these type of functions.
That's what it is. Because it's not always the case.
Not exactly, because you don't always have to have a trinomial. You can have a binomial. Or even you can have like
One
term
where you might say
and that's it, stop there. So you're not going to have the
you're not going
constant
to have a constant.
at the end. Yes, but you're still going to need to substitute your x's for 0. So maybe everything is going to cancel, you ended up with 0 at the end. Yeah. So but you see, it's not going to be exactly the same, but really close. So here we have to give our point for the y-intercept. So we're going to have 0 for x, and we're going to have y be equals to negative 15. Okay, now we're gonna graph. So we know our y-intercept is right here in -15. Then we're going to look for our x-intercept, which is going to be -3 and 5. 1, 2, 3, 5. The other point of reference that we're going to have is the vertex. -4, 1. Okay, drawing on this thing is not easy, so I'm gonna try my best. But you know what I'm doing, right? So I go through the points. This is more or less the idea how it will look like.
So turn, yeah.
Why? And you can know that because of the negative at the beginning. The first term being negative, make it upside down. When it's positive, it's upside up.
Yeah.
So you see the negative and then you graph and like, yeah, that makes sense with the function that is given. Yeah, in your calculator. Yes. And you can double check with your calculator. The last thing that is being asked for this problem is increase and decrease. So where the function is increasing, it's coming from the negative infinitive, right, until 4, because we're looking at the x-axis. So the highest point is here, right? So in interval notation, it's going to be from negative infinities all the way to -4. The same thing, but in set notation, you open your curly bracket and you say x such a thing as x is less than -4, and you close your curly bracket. I'm gonna do blue now.
I wonder if they have 2 of those. Pick one.
Pick one, the easy one though.
The easy one. I like the first one better.
We all like the first one. Increase will be that, and then I'm gonna do decrease here. I move the screen now. It's gonna. Okay, if we look at the graph, it's gonna be the highest point, which is -4, right here, and it's gonna go all the way to the. No, it keep on going. It's infinity. So set notation for that is going to be -4.
Hi there. It's currently
Decreasing from -4 to positive infinity. Close. I was in my head. Close parentheses. Now set notation is going to be open a curly bracket. X, such a thing as x has to be greater than -4. No, it's not that bad. When someone explains this step by step, it's kind of like, oh, okay, I can follow it. So we're done with number 1. Are you okay with that? Okay, good. We can go now to number 2. Now we have to figure out the quadratic function for this graph. And we have 2 points. They're giving us the vertex and the y-intercept. This has a really cool formula. It's y equals a, open parentheses, x minus h, close parentheses, square, plus k. Our vertex is -2, -11, and gas. This one H and K. Do you remember that? Yes. And the y-intercept is going to just be a point. It's going to be x and y. So here we have all the values that we need to plug it in our formula. Thank you. Okay, now we're going to plug everything. We're going to substitute everything but 8. That's what we're looking for. And that's the only one that we don't have, the only variable that we don't have a value for. So y is here, -3. Okay, and then x is 0. H is -2. Listen, these formulas are set up to get you. So make sure with the negative number and the negative number formula. Always do your double parentheses and your double signs and then fix them. And then here is -11. So first I fix the sign, negative and negative, we're going to give me positive, raise that to the second power, -11. Now what I'm going to do is the parentheses and exponent. 2 times 2 is going to be 4, -11. It's easy to get confused in here, so I like to go step by step. -3, this is not reading -3, and then I have 4. I like to write in the right way. 4a minus 11, right? Now I need to move the 11 to the other side of the equal sign by adding 11. In both sides, cancel 11. Now I need to subtract 3 from 11. That is going to give me 8. So now I have a equals 4a. I'm solving for a, so I need to divide by 4, both sides of the equal sign. 4 cancel, now I have a is equals to 2. It is common that you're going to get for a 1, a 2, the small numbers, generally. Now we're going to go back to the same formula. Now we're going to substitute everything but y and x. So we're gonna write down the formula again. We have it there. X minus h squared plus k. So now, y I'm gonna leave it alone. I know now that my a is 2. I'm gonna substitute it. X I'm gonna leave it alone. Minus h. H is -2. Close parenthesis is squared minus 11. First, I'm gonna fix the sign. X, and then I have negative and a negative, that is going to give me a positive. The square minus 11. What the square is telling me? That I have 2 parentheses that are the same. To solve it, what I have to do, I have to rewrite it. I have to FOIL. Yes.
Isn't that for the perfect square?
With FOIL. So x times x is going to give me x squared. And then x times 2 is going to give me 2x. And then here, 2 times x, 2x. And then 2 times 2 is going to give me 4. Close parenthesis, minus 11. Now I'm going to simplify inside the parentheses. The only term that I can combine is the x. So I'm going to have 4x plus 4 minus 11. Now I need to distribute the 2 that is in the front. 2x squared plus ax plus a minus 11. Our next step is going to be simplify the constant. That is going to give me a negative 3.
Yeah, so good. That's what we showed.
So that's our final.
That's the function for
So I think we do like reverse things first.
From the first
find
one,
the
they
point.
give you the function and you have to find the vertex and the y-intercept, x-intercept, everything. This one, yep. Now problem number 3. So they asking you to do this one. To sketch the graph, we need to find points. So we're going to start by factoring. Factoring, always open a set of parentheses, find the factors of the first term. In this case, it's going to be x and x. To figure out the first one, you just bring it down. The second one, negative, then a negative, bring a positive. Now, 12. We need to find the factors of 12. I like to start with 1. 1 times 12 is 12, 2 times 3 is 12, and 3 times 4. Which of these factors subtract it together because the signs are different and I'm going to subtract, it's going to give me 4. 6 and 2. I'm going to put the highest number first because I need to match the signs. So that is going to give me the negative 4 that I'm looking for.
I think so.
If you always follow the steps that I use,
Yeah.
when you have one of the coefficients, leading coefficient, you always want to go straight to this and you're going to find it quickly. Now we're going to solve for x. So x minus 6 equals to 0, x plus 2 equals to 0. I'm going to add 6 in both sides of the equal sign. 6 cancel. Now I have x is equal to 6. And here I'm going to subtract 2 on both sides of the equal sign. Cancel. Now we have the x is equal to negative 2. Always we have to give these answers as points. So x, yeah. So it's going to be 6 and 0. And the other one is going to be negative 2 and 0. We can find the vertex as well. Okay, the vertex A, it is 1, B is negative 4. We don't need a pro, we have C, which is negative 12. The vertex is going to be x equals negative b over 2a. And if we plug it in the numbers, it's going to be negative, parenthesis negative 4, over 2 times 1. That is going to give negative, sign a negative, it's going to give me a positive 4. 2 times 1 is 2. If I divide that, I'm going to get 2. That's my x value for the vertex. Now to find the y value, I'm going to plug it in the original function, which is 2 raised to the second power minus 4. Let me erase that parentheses. So negative 4 times 2 minus 12. That is the calculator problem. Oh no, yeah, you're right, 16. 16. Okay. So now the point for the vertex is gonna be 2, 16.
It will be negative.
I have 16. Let me look. Negative 16. Did you figure out the mistake? Huh? To find the negative. You got a negative 16? Yeah. Oh, okay. Negative. Okay.
So then y equals so the vertex is basically like the highest.
The height is the lowest.
Or the lowest.
Exactly, that's what it is. Now to find the y-intercept. Y-intercept, we have to substitute y-intercept x equals to 0, right? So x squared minus 4x minus 12. So we plug in 0 for each one. The same as before. Goes away. Right? Goes away, goes away. So y is going to be equals to negative 2. So our point for the y-intercept is going to be 0, negative 12. So having all this information is a lot easier to go on. It's kind of done to sketch the graph. You find the point. And follow through. This graph is going by, I think, 2, 4, 6, 8, and yeah, 2. So it's more or less around here. Sure. That's 1 point. The other one is 6, 0. Negative 2, 0. And the vertex. 216. So it's a plot of, as I go through all these points, more or less. She can do better than that. Before in the first problem, I didn't graph it, but the axis of symmetry is gonna be right through the middle of the graph. It should be through 2, so that's the closest that I can go.
So it'll be
The axis of symmetry is the value for the 2 from the vertex, the x from the vertex.
Now, I still want to call it meeting, right? Because I need to get all my meetings on one side.
yes.
And this guy and the other guy, right? The A and the other. Or actually, that.
It should be on 2, but I couldn't like.
So I put a vertex. No, right?
They don't have to. For number 2, no. They mentioned the axis of symmetry in number 1. Okay. Just remember.
Alright. Now, in math, I know that if I have 2 variables here, what we call CCS. These are very common goals. Remember, in math, you can forward CCS out. All you do is move.
Are you good? Problem number 4. Okay. Solve the system of nonlinear equation by graphing and abstracting. Show below. And so we have to do the same thing. Factor to find the x-intercept. So x squared minus 7x minus 18. Open a set of parentheses. X and x. Going down the first sign to figure out the second one, you multiply them, negatives and the negatives in your constant. Now factors of 18. 1 and 18, 2 and 9. I'm looking for negative 7. So right there, 9 minus 2 is going to give me the 7. The highest number goes first because I need to merge the sign. Now I'm going to solve for x. 0, add 9 on both sides. Cancel 9, I have x equals to 9. The point is going to be 9, 0.
Which is kind of the same.
Now the second equation is going to be y negative 3 x plus 3. This is a linear one, so it's easier. Equals to 0. Negative 3x plus 3.
So the other will be x negative 2, x negative 2. I just do 1.
Both points. Yeah, I forgot about the plus 2. So subtract 2, subtract 2. The 2 cancel. X equals negative 2. And the point is going to be negative 2, 0. This one, you see, I told you sometimes you're going to have a binomial, a trinomial, a monomial. This one is like binomial. So the only thing that you could pull out is negative 3. So we get rid of the negative. So if I put out negative 3, I will have x minus 1. Negatives and a negative will give me positive. 3 times 1 will be 3. Yeah, we factor in the greatest common factor. So now I have the x minus 1 is equal to 0. Add 1 in both sides of the equal sign. Cancel 1. Now I have x is equal to 1.
So what happens with the negative?
It stays there. It doesn't really affect because if u equals, I equals this to 0, right? And I solve for x. If I equals this to 0, we're going to have negative 3 equals to 0. That is not true. They're not equal to each other. It's nothing that I can do with it. I have to be that. If I don't have, if I just have pull out in x to say something, x equals to 0, I can call that. That is the true thing. So I can say the value of the x is 0. But in this case, because it's a number, I cannot do anything with that. So the point for this one is going to be 1, 0.
When I had cross factoring, the first formula I had cross was 4. And then when
Okay. All these that we figured out were our x-intercepts.
Yeah.
There are lots of. I don't use slide device because I just don't have that time.
Now I have to find the y-intercept of the issue.
This is an x. This is like a y.
The second one, yeah. Yes, that's it. That is the slope. The slope for the linear one, when we don't have the square, it's going to be negative 3. If we follow this, right? So for this function, the linear one, my slope is going to be negative 3. and the y-intercept, which is b, is going to be equal to 3. The quadratic one doesn't follow that. So this one, done. We have the x-intercept, and we have the y-intercept and the slope. Now, for the quadratic one, we have to find we have to work it out, the y-intercept. So again, if you relate that, it's going to be -15, the y-intercept. You cannot connect the ideas like, okay, you do that. So you have the x-intercept, and the 18 is going to be your y-intercept. You can
So let's call,
graph that.
we don't know what these numbers are.
You can graph both of them.
So that means we have
Some people don't get to see it, so you have to go to the next step.
times of what?
So you have everything in here. Your y-intercept for this one is going to be b
Negative what?
equals -18.
Just in the sum.
So those two,
So,
you're ready to graph.
right.
You're ready to graph. You have x-intercept and y-intercept.
and then these same numbers,
The vertex will be at the point you find because you need to know your quadratic where it's going to turn. The highest or the lowest one. And this one is going to be the highest because it's no, it's going to be the lowest because it's going to go like this, right? This point is upside down.
nothing at,
So it's going to be the lowest one you can figure out with the vertex. The vertex, we can find it.
you don't know what numbers they are.
Remember the formula?
What?
That's
Y equals
over to it.
Uh-huh.
-2.
He uses H.
So,
He uses H.
So x negative b is going to be negative times the negative here, and 2, and a is 1.
yeah.
So we have x is equals to negative, and the negative is a positive 7 over 2. That's the y value of your vertex. Now we have to figure out the y value. So, 7 over 2.
Solve one of these for X.
7 over 2.
You're plugging in numbers. You're guessing at that.
Square.
Not do that.
Minus 7.
You pick. Which one do you want to solve?
Negative 15.
Okay. You want to get Y by itself, or you want to move it?
So I have 7 times 7, 49.
You're going to get X by itself, right? Minus 2.
Over 2 times 2, 4. Minus 7 times 7, 49. Over 2, minus 18.
Perfect. Now that you know what X is, you can take this piece of information and plug it in.
In order for me to combine it, I'm going to multiply the second one by 2 and 2 top and bottom, and the last one by 4 top and bottom.
So now that you know this,
Remember that we have the 1 here, and all the denominators have to be the same. So 49 over 4, I'm going to leave it alone, and then 2 times 49, 98, minus 98, 2 times 2 is 4, then I have 18 times 4, 72, 4 times 1, 4. Now that is just subtracting, adding, subtracting. You don't have to worry too much about the fractions if you don't like them. You can do that in the practice.
Like the,
From the top, you can do all that in the calculator.
oh yeah.
You can put all of that, this one, the top.
Yeah. Because I'm trying to do that. And it's really nasty. So 18
Uh-huh. 18, yes.
this guy is a threat.
Negative 15.
already.
So down here we're going to have a negative 30.25 if you put all that in the calculator.
This whole thing right here represents that.
If you put all that in the calculator,
If I put all that, it'll come up to that?
uh-huh.
And then that's being multiplied by y, right? Equal to. But I think it only looks for time. So to see what we did, so it's this. So I did it for that. And now I have another equation that's not there. You can solve the equation with one variable. You cannot solve it with one different. So we got it. We only have one variable. Now what you need to do is you need to use and then move this guy over to the other. First, then take all these guys and move it over there. So let's distribute first. Let's do that. Okay. Here, get rid of this. And remember, you distribute like the mailman. So y times y is y squared.
If you do it carefully, you will get a number.
Right. Equal to. Alright, now take all these guys up and move them over there. So that way it becomes 0. Because you're going to subtract them. Well, how do we move the negative to y? Yeah. We're just adding the rest. How do you move a negative y squared?
The y will just look at the
Yeah, you'll move those.
But you can do the
Let's
whole
go
word.
one at a time. Yeah, you can't.
But that's easy.
That's it.
No worries. So what do we have left over here? Equals. Put the 2y first. Perfect. Now we want to move this guy. Good. Two. Change it. So now we have
My graph, the graphic one, we go to negative
cancel everybody
18,
out, right? What we got now?
which is here, around here,
Y second. Enough.
and then we find our x-intercept,
Because if they did like this, we would have them together.
9 and 0, around here, the negative 2, 0, around here, and the vertex
So, minus.
is going to be
The
around
equal
here.
sign's already there. It's in minus. Sure. I did. It's over here.
Something like that.
Equals.
And then for the linear one, we do the same thing. 1, 0. What is it called? Green.
It's back.
Here.
But it depends. We're
And
putting
the
it in
y-intercept, we said that it's going to be
the same form goes from the highest power down. So this is what you have to factor now. You got to factor that out. What? No.
all
You
3
got a
here.
trinomial. So hopefully your teacher should have taught you how to factor a trinomial. It's up there. Okay.
So connecting those points.
These are your factoring those ways.
In here it's hard to see. These two will connect around here, which I'm not getting to the connection on the top. Down here I got them to connect.
So that's like the four. That's the point.
That is just Solving by graphing, right? So finding that those where they intersect is your solution, is your answer. That's what you're looking for. Because I'm doing this smart board is kind of hard, but by hand, after you do that, you can plug it in. Substitution will be the easiest because you have already the two equations over y. So you have to substitute y. You have y equals x squared negative 7, negative 18, right? And the other equation is y equals negative 3x plus 3. So I will write first my negative 3x plus 3, and I say that that is equals to, because I'm substituting this y by this, it's going to be equals to x squared minus 7, I'm missing an x right there, yeah, 7x, 7x minus 18. So what I'm going to do, I'm going to move everything to this side, because I already have the first term positive, I want to keep it that way. We're going to rewrite x squared, and I'm going to add 3x, this cancel, and now I have these two combined together. It's going to give me negative 4x. I subtract negative 3 on both sides. This cancel, now I have 18 minus 3, it's going to give me, oh no, both of them are negative. So adding them together is going to give me 21. This square, I combine those two, right? And I got messy. Because I combine the two, if I factor this one, I'm going to find those points of intersection. So, open instead of parentheses, x and x, the first sign negative, negative and negative give me positive, and I have 21. It will be 121, 2, no, 3, 7. If I subtract those two, I'm going to get 4. So the largest number first, the smaller one second. So I have the x is equals to 7, and x is equals to negative 3. And those should be your points of intersection. Why choose the x? You can find the y for that one by plugging in.
Here's another way to look at it.
Here.
The same thing that he's talking about. I call
And I do it in blue now.
Here's how I play these.
In this equation, if I plug 7 raised to the second minus 4 times 7 minus 21, right? 7 times 7 is 49 minus 4 times 7.
And here goes my B. And what you're looking for are the two numbers that he's talking about. Same idea. So these two numbers, how do we find those two numbers? Two questions are two numbers that meet two requirements. Requirement number 1, they must multiply to the top number. And then the two.
So you will go here,
two
21, 28 minus 21, right? 0. So y equals 0. So when x is 7, right? Your y is going to be 0. That will be the point of intersection. Did you graph it?
My A was 1. Number that's in front of my X.
7 through 3, that's how I answer you.
My B is 2. My C is negative 1. Follow me on that. Okay, particular coefficient. So my top number up here is what A times times negative 1. That gives me. Yeah, and here goes my D. So I need to find two numbers that will multiply to this.
Okay. Recapping what we were doing. We have to plug in the x value that we found
which number is going to go
into the
here?
linear equation.
12. The positive 12. Which number is going to go in here with y minus?
So we have, we're going to start with 7.
Now, we
We
want
have
to get our
negative
number.
3, open parentheses,
Okay.
7.
So we need to solve these. How do we solve these small little
So
parentheses out? No, if I distribute, I'm going right back to where I was.
f of 7,
No.
3 times
No. You're going to take each one of these
7,
parentheses.
it's going to give me negative 21 plus 3.
Stephanie.
That is going to give me a negative 18.
Y plus 12 equals 0. Take the other parentheses, that is equal to 0. Y
Now we're going
minus
to do the same thing, but with the 3.
10 equal to 0.
f of 3, I have negative
And now we solve.
3, open parentheses, 3,
This is
plus
what we
3.
call the 0 product. When you
Negative
have two
3
things
times
that are
3
both
is negative
y
9.
equals 0, that means one of them has to be 0. That's
Plus
the way to
3.
do 0. Well, because I have two possible answers. Then you add, what if this guy was the 0? I need my answer for that. What if this guy was the 0? I need my answer for that. So what does y have to equal? How would you solve it?
Okay. I'm plugging in a negative 3. So negative 3 times a negative 3 is going to give me a
So
positive
one of
9
our possible
plus
numbers
3 is
for
going to give me 12.
12. What would y
So my points are going to be negative 3, comma 12, and the other point is going to be 7, comma negative 18.
So in this case, y should be.
Those are the solutions for the graph.
So now that you know what y should be, plug it in and figure out what your
I'm going to go to problem number 5. We're
Go
going to
back
graph
into one of these two and figure out
the
what your
system of nonlinear inequalities.
Okay. I know this is a huge multi-step process because the first thing you have to do is write your equation.
We have x squared plus y squared. We know we have a circle.
All right. So you've got two equations with you.
Your variable doesn't have any number next to
So all you
it.
need to do is
Coefficient. So we know our center is going to be 0, 0.
it's x times what's your first y value.
And the radius is going to be the square root of 25, which is 5. So we're going to go to the center. Mark a dot right there, and we're going to go 5 in each direction. Of 5, on our x-axis, the negative, we're going to go to negative 5, 5 down, and 5 to the
How to get
right.
rid of multiplication?
Now we're going to connect all the
Who do you want to get rid of?
radius
So we're going to divide.
intersection. So close to this circle. I'll try one more time.
So now you're going to do it again with y. Yes. So that's when your y was negative 12 and your x was 10.
Okay, this is a little better.
Now you're solving it again.
That's for my circle. Now,
Change the
the
y value to
linear
10.
inequality. Green, we have negative 2x plus 3y greater or equals to negative 9.
So x equals
So we're
what?
going to solve for y by adding 2x in both sides of the inequality. So let's cancel. Now we have 3y greater
What do you
or
notice they are?
greater than negative 7.
So what?
Sorry for burning off that change. Just gonna then points next to each other. So it's going to be 2x
So
minus
your two
9.
numbers are only what?
I'm going to divide by 3
Two numbers?
each term. 3 cancel, and I have y is greater than
10 and negative 12.
2/3 x minus 3.
Yep. 10 and negative 12.
I
Actually,
have
negative
my
12.
intercept, which is
the
3.
separate the comma. So negative 12, comma, 10.
Y-intercept,
There's a lot to it.
-3 about here,
Now, look here.
and my slope is 2/3.
10.
The slope is right over 1, 2/3, and my y-intercept is -3. So, right there, point should be 0, comma,
It's word problem.
and some of y.
Okay? But your next problem's not word
So I
problem.
go
The next
2
problem
up.
is all about packing. Did you take this guy and do what we talked about? Okay. Try it. Any second number, right?
1, 2,
Your turn.
3 to the right.
No.
That's about here.
Yeah, that's less than reduced, right? Yeah, like that. So if you're top guy, which is
We find
top guy,
x-intercept. We're gonna have a more precise line. For that, I'm gonna equal this to 0. 2
look at that.
third x minus 3. So we're gonna add 3. Each side cancel 3 and I have 3. Each greater than 2/3x. To cancel, it's over x. I need to multiply the reciprocal.
This guy right here.
Both sides need to be cosine. And the quantifier in this case. Cancel, cancel, and have that x is less than 3.39 over 2. My x-intercept is going to be 4.5. It's easier to graph the decimals. Y. So that's another point that I have, 4.5, more of a around here. If I connect all these points, that's it. So how are we going to read this? It's telling me that y is greater than the line there. So greater is going to be up. We're going to use green for the line, the linear. If we solve for y for the circle, it's going to tell me that y is less than or equals to that inequality than the circle. So that means we're going to graph inside the circle because it's less than. So the part they overlap is going to be above the line, inside the circle. And we can use some points to check. We're going to do that with the red. So the test point is going to be -1 and 1. less than or equals to 25. If I solve for that, I'm going to have 1 times 1 is negative 1 times negative 1 is positive 1. And have 1 less than or equals to 25. If I combine them, I'm going to have 2 is less than or equals to 25, which is true. That point is right here. Negative 1, 1 is about here. So it is true. I can check with another point. We can pick I'm going to use the same points in the linear inequality. So I have negative 2, negative 1, plus 3, for the y we're now substitute for 1, greater than minus 9. So if we work this out, negative 2 times a negative 1 is going to give me 2, plus 3 times 1 is 3, greater than negative 9. If we combine those, it's going to give me 5, greater than negative 9, which is true, that checks. So we did the shading correctly. To number 6.
Well, now this is multiply. You want to reverse this. You want to back.
Company purchased new tools for $24,000. He chooses to depreciate the tools over 8 years. Apply a linear function that relates the value of the currency as a function of its age, x. So the original cost was 24,000. If we divide that by the 8 years, it's going to give us 3,000. Function T for tools is going to be equals minus 3,000 because it's going to be subtracting 3,000 from the original cost per year. That's why we have x there representing the years plus the 24,000, which was the original cost. That's our function. Then grab the linear function, label the axis. We can label here 6,000. And here 12,000. And then there's one here 18,000. And here we have 24,000. That is going to be T, which represents the money. Our x-axis is going to represent the years. So we can go Q1, Q2.
You wish I could shoot you.
Three, 4. 6 7. $24,000 is gonna be our y-intercept because right there is how much it costs, how much we pay for them for those tools, and it's gonna be depreciating $3,000 per year. So our slope is gonna be negative, it's decreasing the original price, the value of our tools. And it's going to go all the way down until 8 years because that's the useful life for those tools.
They shouldn't both be negative, so negative times negative should be a positive. Well, that's only because both of them are positive.
As we have the function already said, they asking us what is the value of the tools after 6 years. We know X represents the years. If we write the function that we already set up, I'll substitute in X by 6. We're going to figure out what is going to be the value of those tools after 6 years. If we multiply negative 3,000 times 6, we're going to get a negative 18,000 plus 24. We have different signs. That means we need to subtract and keep the sign of the largest number, which is going to be 6,000. 6,000 is going to be the value of the tools after 6 years. For letter T, they asking to write down the slope in part A. Explain what this slope means in the context of the application. It means that for each year, the value of the tools will decrease by 3,000. And write this out. Value of the tool will decrease by $3,000 per year. Now we go to number 7. The price being in dollars and the quantity X sold of certain product obey the demand equation. So the equation for price is given. Find a model that expresses the revenue R as a function of X. And we know that revenue equals to
This is a positive.
so revenue as a function of X. Yes, because it was X price, 3 in dollars, and
Negative
X price.
positive one is not a positive. Yeah, but you're not thinking about what you got. 6.
Now we have question number 7.
Your beginning and your end.
The price P in dollars and the quantity X sold of certain product obey the demand equation. The equation is given price equals negative 1 over 3 X plus 60. Now in letter A, they're asking us to find a model that expresses the revenue of as a function of X. We know that revenue is earnings that we bring in the company. And that is going to be the quantity times the price. The quantity is being represented by X and the price by P. We don't have any information by the quantity, but we know the function for price. So we're going to substitute P by the function that was given. It's negative 1 over 3 x equals 60. Now we're going to solve. X times negative 1/3 x is going to give us a negative 1/3 x squared. X times 60 is going to give us plus 60x. So that is going to be the model that expresses revenue. Letter B. What quantity X will maximize revenue? What price P will maximize revenue? So to find the maximum revenue, we have to use the vertex formula. Vertex is X equals negative B over 2A. We're going to take the values from our revenue function because that's what they want us to find the maximum revenue. And this function A is going to be equals to negative 1 over 3. And B is going to be equals to 60. So I only need to come here and plug in those values. So I have negative from the formula, and my number is negative 1 over 3. 2 times A, oops, put it on. I have negative 60 being divided by 2, negative 1/3. So I have negative 60, and I'm going to simplify the denominator, which is 2 times 1, 2. So it's going to give me actually a negative 2 over 3. Now negative and negative is going to give me a positive. I know that I'm going to have 60, and I'm going to flip the denominator so I can multiply the two fractions. 60 times 3 is going to be 3 times 0, 0, 3 times 6, 18, divided by 2, that is going to be equals to 90. Now the second question is what price P will maximize revenue. I'm gonna check my revenue equation. Revenue function, and I'm gonna substitute quantity by 90 so I can figure out the price. So I have 90 and negative 1/3, open parenthesis, 90 square, 60, 90, if I solve that,
Good. Wait, why do I?
Square, which is 8100.
No GPS is now. Let you know that. Difference is squared.
8100. 60 times 90, 54. 100. I have a negative 27 after I divide 8100 by 3 plus 54. Different signs, subtract, keep the sign of the largest number, which is going to be positive, and that is going to give me 27. 200.
Did it work? Yes. Yes.
We can check too what price fee maximize revenue.
Yes, you are definitely. They wouldn't want you in this way.
Okay, to figure out what price maximize revenue. We're gonna check price function.
That's what they call it, y equals
We're gonna plug in 90. We want our maximum revenue. Our maximum quantity to maximize revenue, which was 90 units. Now we're gonna plug it in. Price function, and we're gonna solve it. Negative 1 times 9 is negative 90 over 3 plus 60. And 90 and the cost equals to 30 plus 60, which is equals to 30. Maximum price. The price to maximize revenue will be $30. Sure, yeah. Question number 7B. Graph the revenue model as function of quantity. So, label the axis. So we're going to start by labeling. Our y-axis is going to be R for revenue and it's in dollars. X-axis is going to be X and it's going to be units. I'm going to go by 900, 1800, and 700, 36, 100, 145, 100. Our x-axis 90, 180, 270. Our vertex here is 90, 27. So 90, 27 is going to be about here. And then x and y intercept is origin, 0, 0. And our other x intercept is 180, 0. So we graph that. More or less it's going to be here. 160. Let's try. Now we're going to be at 47 million of the revenue function are based on the graph in part E. Just write your answer in set filter and interval notation. It's going to be from 0 all the way to 180. And that's our interval notation. The values are included, so we're going to use brackets in self-filter notation. We're going to open a curly bracket as such a thing as we're going to have 0 less than or equals to x less than or equals to 180. And we can read this as x is going to be in between 0 and 180. Now 7f, we have graph the revenue model as function of price, label your axis. So we're going to start by labeling our axis. Y is going to be the same, it's going to be revenue and it's going to be in dollars. Our x-axis is going to be the price and it's going to be to dollar amount. We're going to label 30, 60, 90, 120. So we have 900, 1800, 2700, and 3600. Our vertex is going to be at 30, 27. More or less around here. Y-intercept and x-intercept is going to be 0, 0, our origin. And the other x-intercept is going to be 16. There we go. I'm trying to grab that the best I can. Perfect. This is going to be the best one so far. find the first, let's first this function. We can go back and use the revenue function. R equals negative 3 squared, so 1 over 80 to find our benefit. We're going to use the formula negative 3 over 2a. Now we can see here that a is going to be equal to negative 3 and b is going to be 180. So as we plug in the numbers, we are going to have negative 180 over 2 times negative 3. We're going to get negative 180 over negative 6. Negative and negative is going to give me positive. 180 divided by 6 is going to give me 30. That's how I figure out the x value. Now if I take the 30 and plug it back in the revenue formula function, we can find our y value. Negative 3, 30 squared plus 180 times 30. So that's 30 times 30 times negative 3, which gives me a negative 2700 plus 54. That gives me that revenue at 30 is 2700. So this is going to be the work. Welcome. Question number 8. A car rental company has 80 cars. Company records show that at $60 per day, they average 56 rented cars. At $80 per day, 21 cars are rented, while at $84, only 14 cars are rented. So AB, using the data to create a mathematical model. Our data is just going to rewrite the information that is given. It's going to be $60, 56 cars, $80, 21 cars rented, and we charge $84, only 14 cars are going to be rented. We have to keep in mind that price is going to be independent. And the number of cars are going to be dependent. Also, we have to keep in mind our main formula when we are working with graphing, which is the slope intercept in x plus b. So if we have this formula and we substitute the numbers, I'm going to use the first data just because the numbers are smaller. Substitute y by 66 and x by 60. I don't have the slope. And I don't have the slope. So to figure out the slope, it's going to be the difference between the points that are given. You can go ahead and use the formula yx minus y1 21 minus 56 over 80 minus 16. We're going to have 7 over 4. Negative 7 over 4. So the difference between those two is going to be negative 7 over 4, and the difference between those two is going to be negative over 4. So the slope is going to be negative 7 over 4. The slope is negative. 1 5. Okay. If I add 1 5 and want both sides of the cosine, it's going to cancel, and here I'm going to get that it is equals to 161. So my mathematical model is going to be the number of cars right here. This is the organized number of cars equals to negative 7 over 4. Plus 161. So part B is asking how many cars will be rented at $68 per night. We're going to be room, the number of cars equals to negative 7 over 4. $68 plus 161. That is going to give me negative 119 plus 161 equals to 42. So 42 cars will be rented. Letter C, we can do the rest. Is the rate of $100 per day reasonable? Is the rate of $100 per day reasonable? Use your model to determine if his rejection is reasonable. Explain the results in the context of the problem and be sure to show how you used your model to get those results. So we're going to use our model, which is number of cars equals to negative 7 over 4. $100 plus 161. That is going to give me negative 175 plus 161, which is going to equal to negative 14. So no, it is not reasonable. We got a negative number. A negative number of amount of cars rented. So that means no cars will be rented. Must be solved. Meditate tomorrow. Let's go.